Forests cover a little over a third of the Earth's land surface, and they're very important for generating rainfall, and they're a large store of carbon and biodiversity. About 1 billion people live in forests in the tropics, and many more people rely on them for part of their livelihoods. So they're a very important natural resource that's also very threatened through deforestation. Tropical forests store a very large amount of carbon, and they also are actively absorbing carbon that we release into the atmosphere. Yet we're rapidly cutting down these forests, which releases more carbon to the atmosphere, accelerating climate change, and also stops those forests being able to take back in carbon dioxide. So it's a double whammy, if you like. So by cutting down forests, we're effectively shooting ourselves in the foot and accelerating the rate of climate change. I lead a research group at the University of Edinburgh that works on mapping tropical forest deforestation and degradation. So that we do that through field studies, going to tropical forests and seeing what's changing, and developing methods to use satellite data to map these changes at a broad scale.
So historically, a lot of people have used optical satellite data to understand deforestation and forest degradation, but typically these approaches are beset by problems of cloud cover and also smoke in the dry season when people are burning the forest. So what we're doing by using radar data allows us to see through both the cloud and the smoke, and also to let us have a much better perception of forest degradation. We're also able to extract information about the structure of the forest itself. Now that allows us to tell things like the amount of biomass in a particular area of forest, and from that the amount of carbon. When we know an area of forest has been degraded or cleared, we can then make estimates of the amount of carbon emissions. What we've been doing in the Indonesian case in Sumatra is also integrating some extra data, so from a LiDAR unit on another satellite, and also data from the field, so from forest measurements. And by integrating all those different data sets, we can get quite a complete picture of the forest and also its change over time. By being able to more accurately measure deforestation and forest degradation, we're able to support mechanisms such as REDD, so reducing emissions from deforestation and degradation, which is a global programme of activities which involve direct payments to tropical countries to reduce the amount of deforestation which occurs in their given jurisdiction. So if we're able to provide accurate information, then policymakers are better able to understand what policy mechanisms work to reduce deforestation, and it also ensures the people who are paying those countries to reduce deforestation that the payments are actually having an impact.